Okay, let's start with section 7.1. I was supposed to teach this yesterday in class, but of course we had some snow, so I'm teaching it at home, and hopefully you'll be able to catch on. All right, it's talking about ratios and proportions. First of all, let's talk about this word ratio right here. When I see the word ratio, a ratio basically is the same thing as a fraction. When I think of a fraction, I think of a comparison, like 3/4. 3/4 is a fraction, but what is 3/4? Well, it's a comparison between the top number and the bottom number, 3 to 4. When I talk about ratios, instead of saying 3/4, when I talk about ratios, sometimes I say 3 and then use the word 2, T-O, and 4. So that's how I could write it. Right, sorry, that's how I could say it. I could say 3 to 4. I could also say 3 to 4 even though I wrote it like this. If I write 3 over 4, I could also say 3 to 4. It's a comparison between one and the other. Here's another way I could write it. I could write 3 and then a colon 4. You know, colons from English class. Grammar. So I could also say 3 to 4. Every one of these, 3 to 4, 3 to 4, 3 to 4, it's a ratio or it's a fraction. We're going to stick with the word ratio. It's a comparison. For instance, if I had in my class, let's say I had, I don't know, 3 girls and 4 boys. All right, that means I only have 7 people in the class. I actually do have a class where I have only 5 kids in the class. But, you know, our class is a little bit bigger than this. But I'm comparing how many girls to how many boys. 3 girls to 4 boys. So if I could do this, I could go girls to boys. Notice how I said that. I didn't say girls over boys or girls divided by boys. I said girls to boys. T-O. Girls to boys. Is what? 3 to 4. Let's say this. Let's say we had that same ratio. But let's say we had a lot more girls in class. Instead of saying we had 3 girls in class, let's say we had 15 girls in class. Okay? And I'll tell you what, let's make that a little bit smaller. Let's go 9 girls. Alright, so let's say 9 girls in class. Now watch what we're going to do here. The G represents actually how many girls we have in class, and the B represents exactly how many boys we have in class. This just represents for every 3 girls, there's going to be 4 boys. So if I had a class that had the ratio of girls to boys as 3 to 4, that means there's going to be more boys than there are girls. Just a little bit, but just a little bit more boys than girls in the class. It doesn't necessarily mean you only have 3 girls in this one class and 4 boys in that same class. All right? It just means for every 3 girls, there's going to be 4 boys. All right, so what we're going to do, if they told me we had 9 girls in the class, look what I could do. I could take this G, and instead of G for girls, let's put how many girls we have in the class. How many girls did we say? Well, there's 9 girls. And look what we can do. We can actually figure out what B is equal to. You could do this a couple ways. One way is you could do this. Look, start off with 3. What did we do to 3 to get to 9? Well, we multiplied by 3. 3 times 3 is 9. What could I do to this 4 to get to the number of boys? Well, I took 3 times 3 is 9, so what would I do? I would take 4 times what? 3. 4 times 3, and that would be 12. That means I would have 12 boys in the class. There's another way to do this, and you might have learned this, you probably did learn this in probably elementary school, definitely middle school, you probably learned this stuff. But it's called cross multiplication. Cross multiply, let's write that down. Cross multiply. Alright, now what is cross multiply? Cross multiply is when you have a fraction set equal to another fraction. Then you should be able to solve for that missing variable. This is how we cross multiply. We multiply diagonally. That's what the cross is, actually. Like this, okay? See how they cross each other? This is cross multiplication. This is only when we have a fraction set equal to another fraction. It's not a fraction, I'm just making this up off the top of my head, okay? These numbers have nothing to do with these numbers, I'm just showing you. A lot of people look at this and they say, oh, we cross multiply. 3 times 7, 2 times 5. No, this is not cross multiplication. This is plain old normal everyday multiplication. So that's just 15 over 14. That's just normal multiplication. This is not cross multiply. When do we cross multiply? When we have an equal sign in between two fractions. That's when we can cross multiply. So let's go ahead and do that. Let's cross multiply. So b times 3, or 3b, equals, and then do this, 9 times 4. 9 times, I'll write it down so you know where we got that number. That's cross multiplying, multiplying diagonally. 3b equals 9 times 4. So what do? We go 3b equals, what's 9 times 4? It's 36. Solve for b. We divide by 3, and look what the number of boys is in this class. 36 divided by 3 is what? It's 12, just like we said it was. Remember, I went 4 times 3 is 12, so there's 12 boys in the class. So let's write that right here. So the number of boys, or the ratio, I should say, of the girls to boys in the class is 9 to 12. But if I take 9 to 12 and reduce it, look, 3 goes into that 3 times, 3 goes into that 4 times, it reduces to 3 to 4. So the ratio is 3 to 4. I hope that makes sense to you. I think you've probably seen this before. I don't think this is going to be brand new to you. All right, that's how you do ratios. Here's another situation that we see all the time. I don't know if you are familiar with this, but when you go out and buy a TV, you'll see nowadays almost all the TVs are in this, they call it an aspect ratio. Okay, it's how you look at it, aspect ratio. And the aspect ratio of a lot of TVs today, especially the high definition TVs, I mean, that's about all they sell anymore. I mean, I don't even know if they sell any regular definition TVs anymore. They're almost all HD. But if you look at the aspect ratio, you'll see this number. You'll see 16 to 9. This is a aspect ratio on a TV. And I just happen to have a couple TVs right here. How about that? All right, let's take a look. I've got two TVs. They're both in different aspect ratios. This one right here is 16 by 9. That means for every 16 you go this way, you're going to go 9 up and down. All right? That doesn't mean this has to be 16 inches this way or 9 inches this way. It means for every 16 you go this way, you go 9 up and down. So I could go 32. What if this was actually 32 inches across like this? Then what would this be? Well, I went 16 times 2, so I'll just go 9 times 2, so the length of this would actually be 18 inches. All right, that's a 16 by 9 ratio. What's the old ratio? The old standard TV. If you look at my classroom up in the corner, you'll see an old standard TV that's not 16 by 9, it's actually 4 by 3. Does that mean it's only 4 inches across and 3 inches up and down? No, of course not. Okay, that's a lot bigger than just 4 by 3. I actually had a little TV on a little radio that I had. My wife gave it to me when we were just dating before we even got engaged. It's a little 4-inch TV, so that might have been, it was probably even smaller than 4 by 3. But anyway, yeah, they did make TVs that were really tiny. But anyway, it used to be a 4 by 3 aspect ratio. And it means for every 4 you go this way, you're going up and down 3. As you can see, this is a lot wider compared to the height. The width is a lot greater compared to the height as it was before. That's why you get that widescreen look to it. And this is a little bit more square. It's not exactly square. If it was exactly square, then it would be, what, 4 by 4, or that would reduce to 1 by 1. So it's not a perfect square. It's a little bit longer this way than it is up and down, but not a whole lot. The widescreen is a lot longer width-wise as it is height-wise. So that's something that we see all the time. And that has to do with ratios. And you'll see this. You'll see the colon on there. And that means 2, T-O, 16 to 9. And that's, just thought I'd throw that in there just because it's something that we see quite a bit, especially if you're shopping for a TV or if you see TVs on commercials and they're selling them and that kind of thing. They'll almost always say it's 16 by 9. But that's so common now. It used to be where it wasn't common at all. Same thing with computer screens. Computer screens are the same way. A lot of computer screens now are widescreen as opposed to 4 by 3 format. Okay? I just thought I'd throw that in there because that's a little bit interesting. Stuff that you see all the time. Here's another thing, if you follow sports or baseball, you use ratios all the time in baseball. For instance, batting average. Batting average, okay, is definitely a ratio. All right. So, for instance, let's say, how do you find the batting average, by the way? The batting average is the number of hits you get to the number of, we'll call it ABs, okay, at bats. How many times you get up to the plate, that's how many at-bats, and how many times do you actually get a hit. All right, well, most people don't get a hit every single time they come up to bat. In fact, even if you're really, really, really good, I mean, we're talking like, all-star good, you're only going to get one hit out of every 3 at-bats. If you can get one hit out of every 3 at-bats, you're probably one of the best hitters on the team. That's kind of crazy, but that's true. All right, so that means you can actually fail 2 times out of every 3 and still be the best player on your team. That's pretty crazy. That's how hard it is to hit a baseball when you're talking about major league pitching. Anyway, let's do this. Let's throw some numbers in here. Here's an example. It's in the book. I'm just grabbing this from the book. But let's say this this one guy, did they give him a name? Joe Mauer. Okay, he plays for the Twins. He gets 181 hits out of 521 times at bat. So he's up sometime during the season. He actually steps up to the plate 521 times, and he gets 181 hits. If you look at it, I mean, look, he's up to bat 500 times, and he doesn't even get 200 hits. That doesn't look like it's a very good batting average, but it actually is when we do the math. Throw that into a calculator. It's actually a division problem. 181 divided by 521, and you'll get a decimal. It'll keep on going. All right, but we'll just round it to this right here, 0.347. We don't really say, when in baseball, if anybody's familiar with baseball, we don't say, well, he's batting .347. We don't say that. We just say he's batting 347. All right, that's actually an average, his batting average. How many hits does he get compared to how many times up to bat he has? So 347 is awesome. I mean, if you're hitting 347, you're going to be probably the best hitter in the entire league if you hit 347. That's really, really good. But why do I show this? Because we're talking about ratios. This is a ratio. I'm comparing. It's a comparison between, in this situation, how many times does he get a hit compared to how many times does he come up to bat. You could do it with all kinds of things in sports. I mean, you could, free throw percentages. How many times does he make a free throw? Now, in basketball, if you're making a free throw, which means, it's where you step up to the line, you get fouled or whatever, and you make a shot just standing on the foul line. To be good at that, you're probably in the 70s or 80s. If you get in the 70s or 80s, probably even some of the really good players actually can shoot 90% or higher from the free throw line. There's not a whole lot of guys that can do that, but that's a really good number. So if you only shoot 347 from the foul line in basketball, you're not a very good foul shooter. But if you play baseball and you hit 347, you're about the best that there is in the league if you're able to hit 347 for a whole year. All right, enough sports talk. Let's do a geometry thing now. So far, I've only compared 2 numbers to each other, okay? For instance, I'll just use letters to represent the numbers. I've just said A to B, all right? I could have written it A over B. I could have written it A and then the word TO to B, all right? Either way, we'll probably use this and this more than any other. And a lot of times we'll just use this as a ratio. You could also extend it out. You don't have to have just 2 of them. You can compare more than 2 things. A to B to C. You could keep going to D to E to F and keep going like that. Let's just stop right here for a second. You can compare 3 things to each other. Okay, one number to another to another. Right? For instance, if we had a triangle, let's draw a triangle here, and it doesn't have to be anything special. Just be a regular basic looking triangle. This looks like a obtuse triangle. Doesn't really matter. So what if they told us this? What if they told you the ratios of the angles? They're not telling you the actual measurement of all 3 angles. They're telling you the ratio of them. For instance, if I said, forget the angles for right now, what if I said the ratio of these 2 sides was 2 to 1 or 2 to 1? What does that mean? Does that mean the one length is only 2 inches or 2 feet or 2 meters to 1 inch or 1 foot or 1 meter? No, it means for every 1 whatever you go on one side, the other side is going to be twice as big. All right? So for every 1 you go, the other one goes 2 times that. That's what you're saying. That's what we're saying right here. It doesn't mean that the length is 2 and the length is 1. Same kind of thing here, except we're comparing 3 things. Since we have 3 angles, we're going to compare 3 things. This is example 2 from the book. Let's do a different color. I'm tired of this yellow. Watch. Example 2, and it's on page 458 if you want to follow along in the book. Okay, it says the ratio of the measures of the angles in this triangle is 3 to 4 to 5. 3 to 4 to 5. Now, what does this mean? Does that mean that this angle is 3, this angle is 4, and this angle is 5? Of course not, because what has to happen to all 3 of those angles? They have to add up to 180 degrees. So it can't be 3, 4, and 5, but what it is this. This is 3 times a certain number, this is 4 times the same number, and this is 5 times that same number. Well, what is that number? I keep saying. I said 3 times a number, 4 times the same number, 5 times the same number. What is that number? I don't know what it is. So what are you going to make it? Let's just make it x. So this angle right here, it's not just 3. What is it? It's 3x. What about this angle down here? It's 4 times that same number. So it's 4x. What's this angle right here? It's 5 times that same number, or 5x. Now the 3x, the 4x, and the 5x actually represent the angle, the actual measurement of those particular 3 angles. All right? Hopefully that makes sense. Because 3 times x equals whatever that angle is equal to. 4 times x equals whatever that angle is equal to. This one, 5 times x equals whatever that angle is equal to. Well, what do we know about all 3 angles? I said it earlier. Excuse me. What's true about all 3 of those angles? Well, they add up to 180 degrees. So guess what we're going to do? Watch this. We're going to go 3x plus 4x plus 5x. Okay, now this represents what that actual angle is. So does this, and so does this. So if I add up all 3 angles, what do all 3 angles add up to be in a triangle? Yeah, we've talked about that a whole bunch. That's equal to 180. And now, look what I can do. Remember I said I want to find that missing number, I want to find what that x is? That's what we're going to do right here. We're going to actually solve for x. So let's do the math. 3 and 4 is 7, and 5 is 12, so that's 12x equals 180. And then when I divide by 12, I get x equals 15. Now the question says, find the measures of all 3 angles. It doesn't say just solve for 15, or solve for x, which is 15. It says find each one of these 3 angles. So, we've done this before. I just got to plug it back in. So look at this one. This is 3 times x, which is 15. 3 times 15 is 45. So this angle right here is 45 degrees. Let's find this one right here. What would that be? Well, it would be 5 times 15. Or sorry, not 5. 4. I don't know why I said 5. 4 times 15. And that would be 60 degrees. See? This angle right here is 60 degrees. This one right here is 5 times x, which is 5 times 15, which is 75. And so those are my 3 angles. 45, 60, and 75 degrees. Let's circle them. That's one angle, that's another one, and that's another one. If you wanted to, you could add them up. Look, 45 and 60 is what? 105. 105 plus 75 is 180. So sure enough, they all add up to 180 degrees. This is really the main example that I want you to get. Okay, this is the kind of stuff they're going to ask you several questions that do this kind of thing. Okay? So how did I know to add them to 180? Because they're angles of a triangle. What if it said that 2 angles were complementary? Then I would take the 2 angles, whatever it was, let's say it's 3 and 4. I would go 3x plus 4x equals, if it said complementary, I would make it equal to 90. What if this was a quadrilateral? What if we had 4 different things in my ratio, and it was a quadrilateral, 4? I would add them up and set them equal to what? 360, that's right. 360 degrees if there's 4 of them. All right, this happens to be 3, it's a triangle, so we add them up, set them equal to 180. All right, I believe that's it. I think I covered everything on this. So that's ratios. Oh, you know what? One more thing. Let's do this. We kind of did this with the cross multiplying. I want to get a little bit more detailed with that cross multiplying. Let's go with this orange. Let me find a good example to do. Here's one that they'll give you. they'll give you something like this. Equals. This will test your algebra skill just a little bit. It's not real hard. It's not much different than we've done before as far as the algebra. But what it says is to solve. Solve. What are we solving for? Well, x. X is the only thing we don't know, so that's what we're solving for. So watch carefully on this. Let's go to this color. What I'm going to do is I'm going to cross multiply. So multiply diagonally. So when I have a fraction set equal to another fraction, how can I solve for the missing variable? I can cross multiply. So I multiply those together, and what do I get? I get 8x. Put an equal sign, then multiply these together. Now you got to be careful. This 5 is being multiplied by something that's being added right here. 5 times a sum. I must put that in parentheses. So it's going to be 5 times x plus 3. See? That x plus 3 has to be in parentheses. Make sure that you do that. And now I can go ahead and just do some math, do some algebra, and then solve for x. Let's do it real quick. So 8x, distribute the 5. We've done that before. So that's 5x plus 15. Subtract a 5x from both sides. So that's 3x equals 15, because that cancels out. Divide both sides by 3, and x equals 5. And that's all they want you to do there is just solve for x. So there you go. It's just a little bit of work. You just have to do a little bit of math, but you cross multiply. They're leading you up to stuff that you're going to do later on. Okay, this is pretty basic stuff right now, but we're going to actually set up some geometry to come up with these kind of ratios, and then we're going to eventually have to solve for it. By the way, let me give this word. When you have a fraction, watch this. If I have a over b equal to c over d, when I have a fraction set equal to another fraction, we give that a big fancy name, and we call that a proportion. Okay, so the one fraction by itself is a ratio. So if I just had like a over b, that would be considered a ratio. All right, it's just a comparison between two numbers. When I have a fraction set equal to another fraction, or a ratio set equal to another ratio, I call that thing a proportion. So that whole thing is a proportion. So I will use in later lessons, I'm going to use that word proportion quite a bit. And I will use the word ratio as well. So I want to make sure that you know what this is. That's proportion. All right. Let's give you a few problems to do, and then you can be on your way, work on those, and then have them finished for tomorrow. Now, tomorrow I'm going to go over a few, since I'm not going to be in class, I'm still going to pick out a few problems from the homework that I'm giving you tonight, and I'm going to go over them so that you can kind of see what you should have been doing in your homework. So if you had any questions on it, tomorrow we'll answer some of your questions. You can't really ask me the questions because I'll be in Florida enjoying the nice sunny weather. But at least I'm going to try to pick some problems and then do them for you, and that might be able to help you a little bit. Okay, let me write down the assignment. All right, there's your assignment right there, section 7-1. And it's pages 460, 461, and we're doing 12 to 28. So this is from the book. Make sure that you write the section number on the top of your paper. So make sure your name is on there, the section number, the page, the numbers that you're doing, all that good stuff. Make sure you do it in pencil. You do it on loose leaf notebook paper. And I'm not going to have you turn anything into the substitute this week. I'm going to have you wait and turn everything in on Monday so that I have it in my hand. Alright, so there's your assignment, 460, 461. We're doing 12 to 28. Alright, have fun with that. Enjoy it. See you tomorrow.